Okay, a lowest common multiple, which is LCM I don't know why there's an S there. LCM is yes.
The smallest number.
Which shares the whole group as a factor. So, I don't really care if you don't get the definitions, as long as you can work with them, which we're about to do. Okay? You can find an LCM by using prime factorization again. And to do that, you must count all the prime factors of the group. But there's a rule here. Only once. What? You're going to see what I mean right now. Let's do both of these. So, we know that 54 is 2 times 3 cubed, correct? And we know that 162 is 2 times 3 to the 4th, correct? We already did those trees, right? Okay. So, to do a GCF, I say you got to count all the common factors. Is there a 2 in both numbers? Yeah. Yes. So is 2 common to both numbers? I know, I did it on purpose. I wanted to get my little pink light back. Is 2 common to both numbers? Yeah. Yes. So I write the 2. Is 3 common to both numbers? How many 3s? 3 3s. 2 times 3 cubed is 54. So 54 is the greatest common factor. What? How can 54 be a factor of 54? 1 times 54 equals 54. So 54 is a factor. 3 times 54 equals 162. So 54 is also a factor of 162. Does everybody see? Now please notice, what did I do? When they were common, I took the smallest exponent. Everybody see that? Okay. Now, let's do an LCM, which we'll do in blue. LCMs say I have to count all of the factors, but only once. Is 2 a factor of both of them? Yes. So I have to count it. Do I count 2 2s or only 1 2? 1 2, because I only count things once. Now look at this one. Is 3 a factor? Yeah. How many 3s? This guy has 3 3s. This guy has those same 3 3s and 1 more. I have to count all of them, but only once. So do I need to count these 3 3s? No, because I've already counted them here. Does everybody understand? So 3 to the 4th, which we know is 162. What? How can 162 be a multiple of 162? Well, just like my example up there, 1 times 162 and 3 times 54. Both equal 162. So that's why 162 is the lowest common multiple. Now you're going to practice this 4 times on the next page. First one I'm going to do completely with you. Second one I'm going to let you do a little on your own. And the last 2 you're going to do completely on your own. Turn the page over. Let's start with 36 and 120. Step 1 is always make the tree. Do I want to force you to make the tree the same way I do? No, because it doesn't matter, does it? You're going to get to the same answer. So everybody make the tree for 36. I bet, actually I'm going to wait a minute and let everybody write their factors. Wait a moment. I am betting that 8 kids in the class have 6 times 6. Who had 6 times 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Damn. Okay, that's cool though. I am betting a few people had 9 and 4. Of course. Did anybody have 12 and 3? Sweet. Did anybody have 2 and 18? Sweet. Because does it matter? No. The only thing that matters is you keep going if you haven't hit a prime. So from 6, 2, and 3. Are those prime? So I circle them. And from this 6, 2, and 3. And then I write it out like an exponent. 2 squared times 3 squared. Everybody should be able to get to there, yes? Right? Why are you looking so confuzzled? Not you, Carmen. What part? I need to know what part it is. So, because 2 times 2, there's 2 2's there. 3 times 3, there's 2 3's there. Okay? And 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. Okay. Now let's do 120. Everybody pick their first 2. I am betting that 20 of you go 12 and 10. No. Really? When it ends in 0, you wouldn't go 12 and 10? No. What did you do? 3 and 40? No. 2 and 60? No. Crazy! It ends in 0. Why wouldn't you use 10? How many people did use 12 and 10? Well, this time I'm total. But, Jade, what is the important thing here? Does it matter? Would you ever erase your work to write 12 and 10 right now? No. Of course not. Why? Because it's going to end at the same branches, right? So let's go. 3 and 4, 2 and 2. There's my first 3 primes. 2 and 5. So I have 2 cubed times 3 times 5. Everybody should have that when they get to the end. Right? Okay, well, let's find our GCF and our LCM. GCFs I like to use red. Here's the way I like to do it. I write them both out. 2 squared times 3 squared. And 2 cubed times 3 times 5. Right? Now for GCF, I check everything common. Is 2 common? Is 2 in both groups? So I need a 2. Is 3 in both groups? So I need a 3. Is 5 in both groups? No, so I don't need 5. Now I got to decide how many I need. This guy has 3 2's. This guy only has 2. What is the greatest amount of 2's I can get out of this group? 2. So I need 2 2's. What is the greatest amount of 3's I can get? I need 1 3. What is 2 squared? 4. What is 3 to the 1? What is 4 times 3? 12. 12 is the greatest common factor here. Everybody cool? Now let's do the LCM. I like to do my LCMs in blue. Again, 2 squared times 3 squared, 2 cubed times 3 times 5. I have to count everything how many times? Once. So I got to count 2's. This guy has 3 2's. Do these 3 2's cover those 2 2's? Yeah, so I don't need to count them because this guy's already got them covered. Does this guy's 3's cover this guy's 3? So I don't need to count him. Do I need to count the 5? Because I count everything once. So I got 2 cubed times 3 squared times 5. 2 cubed is 8. 3 squared is 9 times 5. 8 times 9 is 72. 72 times 5, you'd use your calculator, is 360. Can everybody do this? All right. Let's you guys get to here by yourself with 18 and 24. Go. Get to the point where you have the list by yourself. I'll wait a moment so everybody gets to the list. Is everybody at the list? What is the list? What is 18? Braden. 3 squared times 2. Perfect. What is 24? Oh, Braden again. 2 cubed times 3. Everyone agree? He's absolutely correct. Now we'll work on the GCF and the LCM together. GCF. 2 cubed, 3 squared, 3. What's common? Is 2 in both of them? Yep. What's the biggest amount of 2's that are in both of them? This guy has 1 2, this guy has 3 2. What's the biggest 2's I can get out from both? 1 single 2. What's the biggest amount of 3's I can get out? 1 single 3. What's 2 times 3? 6, and that's my GCF. LCM. 2 times 3 squared, 2 cubed times 3. Count everything once. This guy has 1 2, this guy has 3 2's. Which one do I count? 1 2 or 3 2's? 3 2's, because I got to count everything once. So this guy's 3's cover his. What about here? You should be starting to see a pattern. Here, we took the smallest exponent. Here, what are we taking? The biggest exponent. So what are we taking here? 3 squared. 2 cubed times 3 squared. 2 cubed is 8. 3 squared is 9. What's 8 times 9? 72. And that's the biggest number. Is everybody cool? GCF, smallest exponent of the commons. LCM, biggest exponent, but you count everything. You good? All right. You are going to attempt C and D completely by yourself right now, but I'm going to add a wrinkle. I am going to add a number to the 45, 75. I'm going to add 15. So now there's 3 numbers there. Do you think anything changes? No. Make your lists, count. And on page 24, I am going to circle what I want you to do. The answers are over here so you can check your work. All right? If you want right now, go to page 24 and circle what I'm going to get you to do. C, E, and F. A and D in 9. I'm going to get you to do B and D in 11 because you can barely see A and C. And then 13 and 22. I expect them to cause a bit of trouble, 13 and 22. And you have 12 minutes with which to work. You will notice, what is the next thing on my list? Quiz 1. So I'm going to go to the board. You people are Form 10. So you have page 24 and a quiz for Wednesday. Wait, today's Wednesday. Thursday. Are quizzes anything to be stressed about? Why not? Do they count against your mark? Why do I give you quizzes? To see if you are ready for that particular part of the unit on a test. If you do badly on the quiz, when should I see you? Lunches, after schools, X blocks, right? Go. Now, ladies and gentlemen, 1 second, Simrith, 1 second. I am going to turn off the screen. I am going to do these 2 questions, so the work will be available to you at the end of today's video, so you can check it. All right? Okay, Simrith, yes. Yes, I will be right there. Give me 1 minute. Should any of you be completely stuck right now, your first step is what? Do the factor trees, right? Even if you can't remember the rest, you've got 5 factor trees you could be making right now.